Part 2 of Unit 1 is on the scientific method. The scientific method begins with an observation about a particular natural process or event. A hypothesis is a possible explanation for the observation. A hypothesis is considered to be an educated guess, and only those hypotheses that can be tested should be considered. Here's an observation and a hypothesis that may be used to explain this event. My toaster doesn't toast my bread. Why doesn't my toaster work? Maybe there's something wrong with the electrical outlet. The hypothesis would be, if there's something wrong with the outlet, then my coffee maker will also not work when plugged in. I plug my coffee maker into the outlet, my coffee maker works. Perhaps there is another hypothesis that explains this event. A hypothesis must be testable. You must be able to accurately measure and record data to prove or disprove the hypotheses. Here's some other hypotheses that are testable. If you eat more vegetables, then you lose weight faster. Or if you take vitamins every day, you will not feel so tired. Another hypothesis could be if you brush your teeth regularly, you will not develop cavities. Is this a hypothesis? There are really such things as aliens. Well, some of you may believe in aliens, and some of you may not, but unless we can test all the reaches of our universe and rule out that they do not exist, we can't really say for sure. A hypothesis must be falsifiable. Falsifiable does not mean false. It just means that it can be proven false by observation of results. Eggs lead to heart disease. This is one hypothesis that has recently been proven false. The Earth is round. It used to be thought that the Earth was flat. If you went too far by land or water, you would fall off the Earth. Plants do not require sunlight. Let's look at a sample experiment. So I made the observation that my neighbor's flowers in pots on her front porch grow much faster than mine. And so I asked her if there's anything specific that she does for these plants. And she says that she uses Miracle-Gro on them. So my hypothesis could be that Miracle-Gro will increase the growth rate of flowering plants. So I decided to set up an experiment. I'll grow one pot of flowers with Miracle-Gro and another pot of flowers without. In good experimental design, you would set up two groups, a test group and a control group. The test group would be the group that received Miracle-Gro, and the control group of plants, the plants that didn't. All other conditions need to be kept constant, except for this experimental variable, the addition of Miracle-Gro. Sometimes data may suggest a correlation. A correlation between two variables does not imply that one causes the other. Let's look at this fictitious study. Does the lack of pirates cause global warming? If you took information concerning the average global temperature in degrees C and the approximate number of pirates worldwide, you'll see that as global temperature increases, the number of pirates decreases. While these two values show a correlation with each other, there obviously isn't any causative effect. When setting up an experiment, you always have one experimental or independent variable, and this is what's being manipulated in the experiment. From our sample experiment about the addition of Miracle-Gro increasing the growth of flowering plants, the addition of Miracle-Gro would be the experimental or independent variable. You can only have one experimental or independent variable per experiment. The dependent variable is what you are measuring, and it has to be a value that can be accurately measured to demonstrate a change. The dependent variable is affected or influenced by the addition of the experimental or independent variable. From our sample experiment, the addition of Miracle-Gro is our independent or experimental variable. And there might be several ways that we can measure the dependent variable. We can measure the size of the plants. We could measure the number of blossoms per plant. We can measure the overall width of the plant. But it has to be something that's accurately measurable and shows a change over time. Control variables are not the same as a control group. A control group is where the experimental or independent variable is eliminated. Control variables are all other factors that need to be kept consistent between the test group and the control group. For example, in the experiment with the flowering plants, we want to make sure that we use the same types of flowers, that the size of the flower pots were the same, that each of the flower pots received the same amount of water, that each of the flower pots were receiving the same amount of sunlight. If one of the pots was in the sun, where the other, where it was located, was more in the shade, we really wouldn't be able to determine whether it was the addition of Miracle-Gro was affecting the growth of our plants or whether the lighting conditions. Once an experiment is completed, you'll be able to come up with a conclusion. And this will indicate whether a hypothesis is supported or not. And it's fine if a hypothesis is not supported, such as the little sample experiment we discussed with the workings of the toaster. Experiments should be able to be repeated and have the same results time after time. It's a goal of science to understand the natural world. When various hypotheses have been found to be true repeatedly, they can form a scientific theory. The cell theory states that cells are the basic unit of life and that all cells arise from pre-existing cells. The theory of evolution by natural selection is the process by which organisms change over time as a result of changes in heritable, physical, or behavioral traits. A scientific law is the description of an observed phenomenon. It doesn't explain why the phenomenon exists or what causes it. Scientific laws are universal and absolute. An example of this would be a law of gravitation. If you were to throw something off the roof of your house, it would fall 9.8 meters per second squared until it hit the ground. There isn't any altering of this phenomenon.